Good morning, everybody. Yeah, welcome to today's training. So yesterday we let's discuss a little. So yesterday we talked about so many things. Can someone give us a summary of what was discussed yesterday? Anybody? A summary? Just a quick summary of what was taught yesterday. Yeah, Lawrence.
Morning, everybody.
Morning, Mr. Lawrence.
Yes. So yesterday we were introduced to the schematics of some of our the access control devices and how they are being connected. This is just a summary of what I grabbed from yesterday's class. So from the beginning of the class, we were introduced to those schematics and what they mean, the abbreviations used in them, what they talk about and all that. So we also taught how to connect these devices.
Yeah. All right. That's a very good answer. Thank you very much. Anybody else?
Good morning.
Good morning. Yeah, Everett. Yeah.
Yes. Okay. In summary, we discussed how to connect the hardware to the devices. Talk about the padlock. Talk about the radars. The connection. We have the radars type, which is SR and SR485 connection and WinGuard connection to the devices. So that is the summary of what we discussed. Yes.
Okay. Thank you very much. Chukuma.
Okay. The summary of what we discussed yesterday was about. Can you hear me?
Yes, we can hear you.
It's
clearly.
about how these systems are being connected, and also we talked about open system and closed system. Open system is a system where the system is connected to a network, while closed system are a system where they are not connected to a network. So, and they cannot be operated remotely, while those open network can be operated remotely. And we talk about the funnel. You told us that we start from the physical to transportation to transport and data link layers, and also to application network layer, that if we want to troubleshoot, we'll start from the bottom to the top. So, and you also talked about relays, the open, they normally close, they normally open, and they come. So how to connect it and how they function in the system. Thank you.
Very good. A round of applause. I'm going to give everybody a round of applause. Like, let's give everyone a round of applause. Yeah, all right. It shows we are really paying attention, and I appreciate you all for that. Okay, last person, Juan Docelli.
Okay, good
Did I
morning,
pronounce that correctly?
Yes, you tried. Good morning, sir.
Good morning.
Okay, I've said a lot, but I myself, let me say something. Almost everybody has said or have written down. We talked about one of the major things I learned that yesterday is this connection of this madlock to when it's open, normally open and normally closed, how the connection is being done. Then again, to know that one of the major things again as an installer, when your attention is being called, you should know how the fault should be traced. That the first thing, you have to start from the physical layout, know how the connection is being done, or the wiring connection. After doing that, and you find out that the connection was okay, before you can go back to the next stage, which is the data link layout. Then after checking, then That is another thing that comes to your mind. Now that the connection is okay, now that the wiring connection is standard, let me check for the data link and see if there is anything or the IP have changed or any other things before it goes to the network layout. Let me just stop there because I've said a lot. Then
a round of applause for Iwan Docelli. A round of applause, a round of applause. Like this is really busting my head. It's busting my head. Wow. Nice, very good, very good. So one last person, someone is raising up. Because I want people to give their experience. So Henry, you want to say something? Henry. Okay, I think that was a mistake from Henry. So thank you very much, everyone. Today we are diving deep. We are diving deeper, right? We are diving deeper, and this training you are having, I'm trying to make it as much as open as possible. I'm trying to make it as as abstracted as possible, and also whatever you learn from this training would not only be applicable to ZK products, but would be applicable to any products we are working with. It's an installer training meant for ZK products, but it is important to actually have a good understanding on the principles. When you know the principles, everything else becomes very easy. The principle is what matters. The principle is what guides everything. When you know how things work, you truly know how to approach things, right? And part of the things also is I'm also building an application simple rolled out before the end of this online training. The application is just is like a simulation. It's going to be like a simulation of how your to connect your access control. It's still something I'm working on, and it's going to be free. It's going to be free, and it's not going to be paid. It's going to be out there for everyone to make use of, and I just want us to really pay attention on whatever we are being whatever we are being taught here as regards security solution, right? So we are going to move on. So today we are going to go in depth into the controller, and one particular controller I'm picking out is the Embio Pro controller. So we are going to look at that controller. We are going to look at the terminologies so that you'd have a good understanding of that controller, and the understanding will not be limited to that controller. It's also going to aid you in approaching other controllers, right? One thing I love about I like about ZK products is that one thing I like about ZK products is the products is so ZK products is so abstracted to the point that whatever you learn, whatever experience you have, it stays like it reflects in every other products. So, and that makes it interesting, right? So we're going to be looking at that. So quickly I'm going to share so in the last class, we talked about the we talked about the 1 minute, please. In the last class, we talked about the access control product lines, and one particular area of interest was the ZKTeco controllers, right? If you could remember vividly, and for the ZKTeco controllers, we have them in two parts. Like I mentioned, I said the proximity side. We have the biometric type, right? Where I mentioned the few controllers. I also mentioned the biometric controllers, which is the in-bio controllers, right? So those are mentioned. And so one of the things we'll be looking at today is to really focus on the biometric controllers, right? So whatever I learn on the biometric controllers also extends to the proximity controllers. So the difference between proximity and biometric is just that proximity, as the name implies, deals with cards, while biometrics, as the name implies, deals with bio, human bio, anything bio, like bio here is biology, right? So biological, like the way is biological metrics, right? Biological metrics. So what are the biological metrics? So biological metrics are basically the features of the human, of a regular human. It's as simple as that. So your features. So using your feature as a metric for authentication. So that's where we coin the term biometrics, right? So we are using your biological features as a metric for authentication. So metrics and those features in cybersecurity, there's there are authentication principles, and these authentication principles, they are classified with who you are, what you are, who you are. Yes. Or if nobody can hear me, can you drop an emoji if you can hear me? Okay. So hold on, let me open the mic. If you can hear me, unmute. So is it that you can hear me but I'm breaking?
You're breaking, sir.
Oh, you're breaking
Okay,
in.
Hey, breaking.
You clearly.
okay.
Breaking.
So okay, so what I'm going to do now is I'm going to switch my network in a minute, then I'll ask again. So give me a minute, let me switch my network. It's breaking. Can you all hear me?
It's better now. It's better now. It's better now.
Yeah, I
It's
can
better.
hear you.
Yeah, we can hear you.
Okay, very good. All right, so let's continue. So two factors, two biological principles, right? They are split in two types, right? I know we are access control installers, but you need to understand things from first level principles. And in cybersecurity, there are two factors there are two mechanisms that helps in establishing highly defense mechanisms. And those factors are these two factors you see here: who you are and what you have. So who you are is what's inheritance is an inheritance factor, right? And what you have is a possession factor. You understand? So who you are is an inheritance factor. What you have is a possession factor. Now, in access control, when we talk about authentication, so I'm going to give you two examples now. So I have fingerprints and I have password. So if I'm going to classify these two, can anyone tell me where I want us to raise our hands? So where do I classify these two? Yeah, Friday.
Okay, fingerprint is who you are because it's inherited with you, and why password is what you have.
Very good, very brilliant, very brilliant. So I'm going to give, so that's 10 marks for you. That's very good. It's actually pretty much obvious, right? You understand? So now let me give another example. Face palm recognition, palm prints, and card. So anybody, Ahmed.
Okay. Palm print is who you are, and card is a possession. That's what you have. But
Exactly.
palm print is part of you, is your inheritance, like is a features of you.
Exactly. So in the cybersecurity field, these are the two classifications we have. You understand? And this is the standard, everywhere. And so this is the standard. What you have is a possession factor. Who you have is an inheritance factor. So these two so before the advent of this guy, of this classification, this particular guy here. Oh, sorry. So before let me just highlight, before the advent of this guy, the only defense mechanisms we have in this like security industry is the possession factor. That's what you have. And the first set of controllers that were created was proximity controllers. So which are controllers that uses card proximities. And as technology became advanced, there was a switch, and that switch was having a form of authentication that is unique to individuals. So those form of authentication, how do we determine that? Then an incident happened from a twins in Kenya. They've never met, but they're actually twins. And one of the twins actually robbed a particular store. Then the FBI arrested the other one, and when they checked their background, they saw that they're actually twins. And how could they distinguish them? Then they used their that was what bettered the fingerprints, factor. Everybody has like unique fingerprints, right? And from there we started looking at other biological features that are unique to us that we can actually, use of. And so that bettered the inheritance factor of, security authentication. So the latest one is the biometric controllers. Biometric controllers that supports the authentication of biological features. That's the use of fingerprints, the use of cards, right? So now I'm going to share my slides this time. We are going to look at one of the key popular controller, the InBio. And in the last class, we mentioned that the InBio comes in about there are three types. You have the InBio 160, you have the 260, you have the 460. Can anyone tell me what InBio 160 is? InBio 160. When I say InBio 160, what do I mean by that? Yeah, I mean.
Okay, the one that has one, is it one face or one what did they call it? Why the 360s one that has three,
No. I think you are missing it. We have for InBio, we have them in three types. We have the InBio 160, 260, and 460. So when I say 160, what do I mean? Everestus, you want to help Ahmed out?
Wait. Let me try. When you say 160, you're actually referring, the 160 there is referring to the number of relays. You can control only one door. The number of relays in the controller.
Yeah, good. So when I say 260, Monday.
Amir, can I speak?
Yeah. I did it.
So when about 260, so the numbers of doors that the controller can control, that is 2 doors.
Yeah, good. Yeah, Monday 460.
Okay, 460.
Four doors.
4 locks, and
Yeah.
4 exit buttons.
Yeah, good. So let's take a look at the InBio, because this is our latest controller, and it is very important for you to understand the controllers. Although in the last last week, I gave a breakdown of the types of controllers we have, not limited to just this, but this is our latest controller. Do you understand? So if you want to learn about the others, you can go back to the last slide, to the last week presentation slide. It's in the week 1 folder, so you can learn more. But today we'll focus on this new controller, and not to worry, whatever this new controller, whatever you're going to learn from this new controller, you know that it is much more advanced than the old controller, and the system is still the same. But the new controller has some additional features. So whatever you learn here applies to the old form of controllers also. So you don't have to worry. So the InBio Pro controller, it's the core purpose is for projects, right? And one of the main reasons why this was developed is because we want to look at ways in which we can combine different biometrics function for this controller to actually, support. And also we want to look at controllers that also take QR authentications. And part of the things we also did on this controller is to ensure that we speak to the security aspect of things, right? Because although Chinese Chinese products, as everyone popularly know, is that the products are cheap. Chinese products are cheap. So since Chinese products are cheap, it means they might not be efficient, and the security standard will be very low. And that is why majority of Nigerian banks, they make use of European controllers, right? European American controllers, like of Pastin, like of Lenel, right? So, but one of the things that um, one of the disadvantages, or I'll not call it disadvantages, I'll just call it one of the shortcomings of those type of controllers, is because the functional capabilities are limited, and they are super expensive, right? And Chinese markets, one thing they do is they try to ensure that uh, they put out products, lots of products at cheap price that is affordable to people. And one of the things that ZKTeco has done is to actually push out controllers that matches and outperforms these expensive European and American controllers. And that was what updated the Inbio Pro controllers. One of the things, um, these Inbio Pro controllers, I'm sure some of us here, we deployed these controllers before. We've used it, even if we don't know about it, we've actually used it in banks, but you'd want to know that why did these banks, why did they accept this type of solution? Why did they accept this controller? The reason why they accepted this controller is because there are some security standards and security requirements that has been met, right? And those security requirements are on these controllers. Some low-end controllers, they don't have the security requirements. But for this type of controller, this security requirement is met. And also the cost the cost implication is very low compared to the other type of controllers. And what do we now want to? So when we now talk about the security standard, there are two types, right? And I'm going to share this tab. The first is the AES 256, which is called the advanced encryption standard. The second is what TLS, the new latest TLS 2.0. This is called transport layer security. I think security here. So these two encryption standards, they are basically for data in general, right? One is meant for data at rest. The second is meant for data in transit. Right. So now, for the one for data at rest, when we say data at rest means data that is residing in a particular device or a particular peripheral, right? That's data at rest. So, for example, you have your controller, right? Or you have your biometric device, like your F18, right? You have your controller, you have your F18 biometric device, and you have 200 users on those devices with 200 fingerprints. These 200 users and 200 fingerprints on these devices, they are data at rest because their data is residing in the devices, right? You understand? That's just data at rest. So then data in transit. Data in transit is now when a user comes and a user authenticates on a device, On the software, let's say this is a software, right? This is a software, right? And these are tiny bits of data. Let's assume these are data. These are data information, right? When a user authenticates, this data would, send at instantaneous speed into the software. So when the user punches on the device, you see the log on the software. You understand? So that log you are seeing on the software, it means that operation that happens, it means data moved from one position, right? Or data is generated from one position to another position. Say you want to transfer user from one device to another, data is leaving that device to another. You want to copy data is replicating from one device and flowing towards another device or the software. That process, so that's time, the time in which these data are moving from one point to another. That operation means the data, they are currently in transit. When you are sending large data and there's this data movement, it means those data are in transit. When you make an operation to facebook.com or google.com, whatever operation you make, maybe you are creating your user account and you click send, there's a data that is flowing from your phone, that's your client, to the software. That data, they are data in transit. You understand? So now, what better this is, we want to look for ways in which wherever these data are, the movement and the movement of this data, we want to ensure that they are encrypted. By encryption, we mean they are not, readable to the normal human eye. So let's take, for example, let's say there's an attacker, right? We have an attacker here, like a thief, like a dark cybersecurity guy, right? You have a dark cybersecurity guy here that wants to, intercept this data that are flowing. The cybersecurity guy is trying to intercept this data from his laptop. He's trying to write codes. So when the data has this transport layer security, it means even if this data gets intercepted, it will become unreadable to them. So it will be scrambled. So let's say I'm sending one simple example is, you're on Facebook and you are chatting your girlfriend, right? Or your wife, and you just message, "I love you, my wife," right? And there's an attacker trying to intercept whatever you are sending, or you are sending a code, a BOQ, right? And you are sending it through WhatsApp. Your data is already, encrypted. So when you're sending it to the other party will only be able to see that data as it is. If the data gets intercepted by an attacker, by this guy here, right, the attacker will not be able to read that data because it will be scrambled, right? So TLS 2.0, the transport layer security, helps to ensure that data leaving from one point to another gets encrypted. And even if there's MIM, the process of this is called man in the middle attack. It's called the MIM in cybersecurity term. MIM. One of the reasons why you have to know this concept is because you get to that point where troubleshooting would also lead you to understanding stuff like this. And you might be doing pre-sales, and questions like this will be asked on why should you use InBio Pro device, right? The banks will ask you why do your this thing has this, so you know that these are the two key things that are required for it to understand. So for the data aspect, the data residing on the device is also encrypted using the advanced encryption standard AES 256. So I'm not going to go into much details about them because you don't need to know like deep about them. So what you just need to know is that these two are essential. So let's go back to this slide. So for this device, it can take a maximum face template of 3,000. This was covered in the last class, so we don't want to dwell too much on it. And the features, like I mentioned, number of controllers 1, 2, and 4, which means you have one relay, one door, 2 doors, and 4 doors. You can see this is highlighted. And for the one door, you have 2 WiGAN interface on the controller, which means on one door you can do reader in and reader out, right? Which means if you have your controller, you can have, since this controller supports just one door, it means you can have a system of authentication in and a system of authentication out with one exit button. For InBio 260, you have 4 reader points. So which means you have a system of, for the 2 doors, you have both system of authentication in and both system of authentication out. That is using the WiGAN card interface. You see, it's called the WiGAN card reader interface. You understand? Then for the 460, you now have 4. Some of us should be thinking, why is 264? 460 should be 8 now, right? Yes, Friday.
Yes, I was about asking. That was actually the question. And then again, what will I be doing with 4 winged on 2 doors? Is it like have, because I know I'm going to have one in and one out, which 2 is a
So
okay,
let's
okay. Yes. So okay. I think that is it. But I actually wanted to know why 4
okay.
4, why this
Yeah.
these 2 are not. Yeah.
So okay, so now let's break it down, right? Now you have, let's start with 160, right? Okay, so let me get a view controller. 1 minute. 1 minute. Okay. Use it as like same. Can you see my device? Can you see my screen? You can see my screen, right?
Yes.
Okay. Yeah. So now let's start with one door. InBio Pro 160. Now let's say here we have a door, right? We want to, okay, let me design a door. We have a door. Right. Sorry, I really have a bad drawing skills. So let's say we have a door, right? And this side is, okay, it's better for me to make this. Yeah. So say we have a door, right? And this side is the inside of the door. Inside of the, this is the inside. This is the inside, right? And this is the outside. We have a room. This is the room. Yeah, the room is here. All right. Someone is trying to join. Okay, so we have a room here, right? This is a room, and this is the door. This is the outside of the room. you know, and this is the inside of the room, right? And this is the door. When you open this door, you go inside. When you are coming back, you go outside, right? So let's now take our in-bio, right? This is our controller here, right? In the slide, we said in-bio 160 supports one door, right? And we have one door, right? Two wide interface. So if it has two wide interface, it means I'm introducing two card readers, right? So let's say this is my first card reader, and this is my second card reader. Let me differentiate them. This is my first card reader, say card reader 1, and this is card reader 2, right?
Good morning, good morning.
So for card reader 1, right, in-bio 160 supports two wide cards, right? So it means I can use this card reader 1, I can use it for inside, for the reader that will be inside, that will be at the door side. Then I can use this reader 2 for the reader that is what? Outside. So which means if anybody is coming, you know, to authenticate on this reader, right? It means they need to come with their card. So if they want to go in, they go in with their card, and if they want to come out, they come out with their words, with their card. Do you understand? So I have my in-bio 160. My in-bio 160 supports one door, and it has two wide reader interface. So it means I can use reader in and reader out, which means I can have a system that makes a user authenticates in and authenticates out. Now, not just that, if I come here, they said there is one exit button. It supports one exit button. It means I can, if the case, you know, I can also have another system of authentication saying I don't need to use this card. I can introduce an exit button, right? So it means I can use card in, exit button out, or card out, exit button in. So it means I can use one reader on this door and button on this door if I want. And if I also want, I can replace this exit button and use card reader on this inside and use card reader on the outside. Or if I want, I can say I don't want card reader on the inside. I want exit button on the inside. I want card reader on the outside. So whatever the case is, I can achieve any of these with one door. Can you all hear me? Am I breaking?
I can hear
No.
you. I can hear you.
Okay. You understand? So it means I can achieve, you know, this. So now, is that clear? Is that clear? Is that clear to us? Thumbs up if this is clear to you.
Yeah, it's clear.
Okay, good. Now, let's move to in-bio 260. Two doors, 4 wide interface, and 2 exit button, right? So take note of about 260, 2 doors, 4 wagon interface, and what? 2 exit button. Now let's go back to our drawing board. Now we have in bio 260. So I'm going to replicate this. I'm going to give it another color. Card reader 3 and card reader 4, right? So I'm going to replicate my door also. So I'm going to replace that door. So now I have 2 doors. 2 doors in BIOS 260. So I'm going to delete this. So I'm going to ungroup this. Okay. So now I have about 260, right? And I have my card reader 1, my card reader 2, right? My card reader 3, and my card reader 4. Right? So the next thing is 2 exit buttons, right? And I have another exit button here. Right? So, and I have another exit button. So for about 260, I have 2 doors. They said it will support just 2 doors, 4 card readers, and 2 exit buttons, right? Now, how can I achieve? So how do I implement? So it means for these 2 doors, I can have one controller, which is one controller. This one controller about 260 can do reader in, card reader out for 1 door. Right? I still have 2 card readers because it can support 4. I can also take card reader 3 and card reader 4 on the other door. You understand? So I've completed my authentication in, authentication out for 2 doors. And also, if I don't want authentication in, authentication out for 2 doors, maybe I want authentication in and exit button out, I can leave a space for the cards and bring in the exit button. You understand? That's clear, right? Good. Now, let's now go to the 4 system. Yeah, Chukuma has a question.
Can you use both card and exit button?
Can you use
Both the card and exit button.
both the card? Yes. That's what I just showed you. For this door, I can say card exit button for this door. Card in, exit button out. For 1 door, I can do card
That's not
in.
what I'm asking. Like what I mean is like, okay, 1 card in and 1 card outside, like card reader outside.
Okay.
Like
1
can
card
you use
1 card
1
out.
card
Mhm.
in, 1 card out, and also another exit button, like exit button.
Exit button on that same door, yes. But
Okay,
in what
okay,
case?
yes.
But in what case do you want to use that? Anybody answer that question? In what case would you use something like this? Can anybody tell me? So Chukuma, you asked that question.
Yes.
No. Wait, I want Chukuma to answer that question because he raised the assumption. You see, before you raise an assumption, right? You have to also, you don't think of the system. Think of the use case, right? I have a use case in my head, but I want Chukuma to raise that use case to speak to a use case in which this can be applicable. There are several use cases, but I want, okay, since Chukuma doesn't have that, an answer to that. So, Evarestos, you want to answer that?
So I don't really, I will not say that there's a particular case for that, but I'm not trying to say maybe in an emergency case, maybe you can use it in a case of emergency. Maybe someone is trapped. You can use this bottle if you don't have the access for the cards. But we don't normally implement it. We normally use break bottle or break glass or something.
Break glass. Exactly.
Okay, and also like in hospitals where they are doing surgeries, so doctors may want to go out and come in. Nurses, like if you come in, you may not necessarily need the card. Like in some cases like that.
Okay, so are you now saying in that case, so in the, like the example you just cited, are you now saying on that door, if I put card here and I put exit button here and card here, so what's the essence of this card here if exit button is here? Now, one use case me I'm seeing is, say you have a CEO's office, right? Your CEO, you know how big CEO's office are now? Your CEO table is here. Your CEO table is here. Your CEO table is here, right? The door is here. Is say, sorry, 3 to 4 meters to the door, right? And there's an authentication in, authentication out already. So whenever the CEO is around, right, you want a system where, because if someone is coming to see the CEO, like a visitor, you don't want the CEO to be standing up and be going to the door every time to access, right? So you can just put an exit button here and the CEO, use the exit button for anyone, coming to visit. That's one use case, right? So, but you can't have a system where you have the exit button at the same position with the card, because what you are just doing here is you basically eliminated this guy. So what's the essence of this guy? If this guy is here, so it means anyone with no authority can. Exit button is basically to give, like, it means something that requires no authority, right? So if anything requires no authority, then anybody can just come. People will barely use this guy. So, right. So in security system, we have to always think of, we've been provided with these functions. We now have to think of use cases in which these functions can actually be applied. So makes things very easy, right? So now let's go to InBio 460. It is said that InBio 460 has 4 doors, 4 WIGAN interface, 4 exit button. Now let's visualize that. So we have door 1, door 2. Okay, I'm going to shrink this a bit. I'm going to delete this guy. I'm going to shrink this bit so we can have space for the others. Let's delete this guy. Let's copy this guy. So we have 4 doors, right? And we have four readers, right? And this is reader 1, reader 2. These are the 4 readers, right? We have 4 exit button. So take note that the readers are what? Card readers. So just take note. And we have 4 exit button. All right. So then 4 doors.
Yeah.
4 readers and 4 exit button. Right. So how do we achieve this? Right? How do we achieve this? First, it will be very difficult to achieve authentication in, authentication out, because the system is not built for that on this panel. What we can achieve is authentication in, authentication out on just 2 doors, right? Because I have 4 readers, right? So what will happen to the other doors? It means the other release will be inactive if I want to use 460. But I have a case where the customer has 4 doors and I want to use InBio 460. What do I do? Fine. If the customer wants reader in and exit button for all the 4 doors, it's very easy, right? Because I have 4 reader and 4 exit buttons. So I can do reader in 1, exit button for the reader in, exit button, reader in, exit button, reader in, exit button. That completes, everything. But for authentication in and authentication out, I can't achieve that. I'm limited. Why? The reason is because for Wigand authentication, the addressing on the controller is fixed. The addressing on the controller is fixed for Wigand authentication. So let me show you something. Then we'll move back. So if I come here, all right. Okay, I'm not going to use this. Let me use, I need a description of the controller. So if I come here to 460, I'm trying to get a clear picture of about 460 so that we can see the reader points. Okay, so let's I can't find one. So let's use this image as an example. So here you see this mapping here. You see this mapping here. You see door Regan 4, door Regan 3, door Regan 2, door Regan reader 1. This is telling you that the position of the readers are fixed on the controller, and the maximum you can have on ZKTeco controller is what? Is 4. I don't know about other controllers. There are other controllers that have more than that. Some other controllers might have more than that. Depends on the number of relays, right? But for ZK controllers can only take 4 WiGAN reader points because of the shape of the controller and the space they occupy. So if you look at the WiGAN, you see that their positions is fixed on the controller. That's why you have the WiGAN reader 1, reader 2, reader 3, and reader 4. So this has caused that restriction for you to achieve the reader in, reader out. But that will now bring us to the use of the RS485 extension, which I'm going to describe. So the RS485, we are going to learn about that. So on the reader, you would see that on the controller, there are 2 points. I'm sure majority of us already have good understanding of the controller. We've seen it before. So the functions that are present on the left flank, you have the Ethernet, you have the deep switch, you have the RS485, you have the aux output, you have the door sensor, you have the lock, you have the power panel. On the right flank, you have the auxiliary, you have the RS485 points. You can see that the RS485 points is just 1 point here. So just take note of that. Then we have the status indicator that shows you the state of the controllers, right? Then you have the exit button, you have the WiGAN, you have WiGAN 2, WiGAN 3, WiGAN 4, you have the exit button 1, exit button 2, exit button 3, and exit button 4. Yeah, Ahmed.
Okay, sir. I wanted to ask, since this thing has like an internet port, that means an IP address could be assigned to it to manage it. That means it will use the BAO software, right?
Yeah. Yes, we are getting there. Just follow through. You understand? We are getting there. Good. So, so these are the points, right? So you can see the WiGAN points, you can see the deep switches, you can see the Ethernet points. So you can see all these parts. So the Ethernet points, just like Ahmed have said, is to ensure the connection between softwares. I'm going to explain that to you. You have the deep switches, you have the extended RS485. This was the logic that was used before the birth of the Ethernet, where you use the RS485 to connect to a PC, more like using the USB. Then you have the auxiliary outputs, to connect, multiple like sound blasters, alarms, and stuff like that. Then you have the door sensor and the lock, where you connect that. You have the lock power. I shared in the slide that I shared yesterday. I shared a diagram that shows the connection of all those things on the controllers. So these are the points. So on the door parts with WiGAN, this is clear, right? On the door parts with WiGAN, this is clear. We are coming back to it when we are talking about the RS485. But let's continue. So now, the power structure, right, for access control is, and this is one of the things I'm going to say. When you want to install access control using the imbibe, the first thing you need to, there are so many architecture. You don't have to follow this architecture, right? But what is important is that you need to ensure that you have a control panel. In BAO 260, in ZK, we sell in BAO 260. And in some cases, some customers might not require like the panel. We call it the package B. Some customers might come with the normal BIOS 260, and some customers might say they require the panel, right? The package B. But it is always advisable that if you are doing your first installation, you always get it with the control box, right? Second is that you have to have a strategic isolation when you are installing, right? Your control panels and electronic locks must be powered separately. An electronic lock generates a strong interference signal. Sharing power compromises the panel world's stability. That's one. Access control management requires at least one UPS. For those of us that we are installing for companies, you have to always quote a UPS, or you have to always ask. Because when you are installing access control, you need to install access control in a place where power is what? Of immense regularity.
Okay.
Because when there's power outage, everything goes off. And one thing you don't want to go off is the what? Is the controller. So if the UPS is the control, and the controller is just taking just 12 volts of power. So if you have a UPS just to the controller, even if there's power outage in the whole facility, the controllers are still what? Are still up and running because they are not taking so much power, right? So this architecture should always be followed. You need to have your control panel, your 12-volt panel, your UPS must be stable, and the locks and the control panels must be powered, separate.
But I need to know your admin name.
So on the control panel, on the controller, you have the points where you power the controller. The controller uses 12 volts DC power, right? And this is the architecture. Your 220 volts coming from your switching power supply, right, goes into a control panel that has 12 volts. InBio Pro Package B will come with that panel. But if you don't have that panel, you can get a switching power supply that converts 220 to 12 volts. You know, all those PSU, power supply units. So you need to purchase them. That is if you don't get the InBio Pro Package B. Normally, the InBio Pro Package B would come with, you can order it with the battery. So you have the InBio Pro Package B with the battery. Battery comes with it. Everything comes in the box. But with the case of Nigeria, I know how our Nigerian market is. People want to do things very fast. So they just say, I need controller. Give me controller. When you now get the controller, you now be looking for where to get power supply, where to get battery, where to get this, that. You understand? So it's very important to, whenever you're making quote as an installer, you're making a proper quote. You are quoting for the InBio Pro Package B that comes with the control panel and the battery. And the 220 volts steps down, the switching power steps down wherever 220 you have. And you can now take whatever 220 you are getting to 12 volts, and you're now taking that 12 volts to the controller here. So you're now taking the 12 volts here to the controller, right? So you're powering the 12 volts here on the point. So I showed us that the left flank of the controller is where the control panel, resides. So you can see it here, right? So the next thing is the networking, right? Which Ahmed talked about. So now, for networking, the every of our products has TCP/IP layer. If I come to this tab, right? TCP/IP, for those that don't know, TCP is called is it transport or transmission? Someone should correct me.
Transmission control protocol.
Protocol. Right. P is just basically internet protocol. right? The internet protocol is a way of identifying peripherals and a way of sharing peripheral systems, right? The internet protocol is a protocol that devices speaks to one another. Our human protocol is called what? It's called language. Language is our human protocol. English language is the fact that you can hear me, the fact that you know that my name is Ife is because you understand English. If you are speaking in your local dialects, I won't even understand you. I won't even know what you're talking about. If I'm speaking in my local dialect and you are not from my, local region, you won't even understand what I'm saying, right? So the protocol in which we interact, humans interact, is called language. The internet protocol is a protocol that allows devices to interact. And for us to interact, what is the first thing we do? Before I started this training, what did I do in the first week? I introduced myself. I said, my name is Ifeoluwa Adefoye, right? And it registers to everybody. I know Friday, I know Ahmed, I know Sodiq, I know Chukuma, I know Evarestos, I know Sholoton, I know Monday, right? And I know Lawrence. I know a lot of people here because I can see your names and you've interacted with me and you've joined the training. So that is human protocol. But in the cases of device, me speaking to you is also a form of data transmission. The fact that you can hear me, I'm relaying the data to you. If I say A, you've picked up A in your head, it means I've transferred data to you. I transferred the data A to you, then you picked it up. This training is a data transmission that is currently existing between me and you guys. And our data is encrypted because we are using Google Meet. Whatever I'm discussing with you guys, no other person in this meeting can understand. That is the human system of communication and data transportation. You understand? Now, for devices, how do they communicate? You see, humans are very intelligent beings because whatever we are creating, we create things as though those things are us, right? We know that for peripherals we are creating, they need to be some sort of data transmission. If I take my phone and I message Ahmed, right? Ahmed gets the message, right? How did my phone recognize Ahmed's phone, right? What is the layer that exists between those things? So first thing we need to know is when we have a device A, and device B. Right? The first thing we want to know is for these two devices, how do they interact with each other? Right? They interact using the internet protocol. And how do they achieve that? In the internet protocol, there's something we call the CIDR block. Does anybody know what CIDR is? CIDR means classless. Anybody? Yeah, Ahmed?
Classless interdomain. Is that a register? Something? Yes, I think so.
Very good. Very good. Classless interdomain routing. So that's what CIDR. And CIDR tells you that we have a subnet of numbers called that's a subnet of bits that computer understands. Computer understands zeros and one. Devices understand zero. The language of devices is what? 0 and 1. So how do we translate these zeros and one into words? We we can easily, use to assign. Then what we now did was to come up with what we call the Internet Protocol addresses. Now, the Internet Protocol addresses are addresses that we use to identify bits of classes of numbers that we use in identifications of peripherals. So the first thing is, so let me give an example. My name is Ifelua Adefe, right? When I was born, my parents named me Ife Olua, right? And ever since then, I've been bearing Ife Olua. Everybody knows me as Ife Olua. That is my name, right? Among my peers, they call me Gandalf. That is my nickname. Now, to liken that to devices, in Internet Protocol addresses, we have what we call the public address and the private address, right? The public addresses are addresses that, as the name implies, public. Yeah, Friday. Oh,
I don't know. You're not sharing yours where you are now. Okay.
sorry.
Yeah, thanks.
Sorry, thank you. Thank you for reminding me. So you have the public addresses, you have the private addresses, right? So the public addresses are, as the name implies, public. They are addresses given to different peripherals to ensure that different peripherals anywhere in the world communicates with each other. One example is your phone. And how do your phone communicate with Google in London? How are you able to call someone? Yeah. How are you able to FaceTime someone from here, someone in London? Yeah. All those things are achievable through public addresses, right? So, but public addresses are limited, right? If we assign public addresses, we only have this range of numbers, 255, which means I can only have from 1.0.0.1 .0 1.0.0 to 2.0.3.0 to 255.0.0, then 255.1.0.0, 255.2.0. I can only have those range of addresses. But even if I have those, as much as they are, we have billions of devices, billions of peripherals. How do we reserve these public addresses to ensure that we still have them reserved? Although we now have a new protocol called IPv6, but I don't want to dwell on that. I want to dwell on something that we all have, we all use every day and have a good understanding of, which is the IPv4. So is the Internet Protocol version 4, right? That's the version. So the public addresses, so there are addresses that allows devices to communicate like all over the world. And how are you able to use your phone to achieve communication with is a Google, someone in London? Let me just say someone in London. How are you able to chat that person? That is possible because you have a mobile network, right? Your mobile provider has already bought a public address, right? MTN or Glo or any network, right? They've already gotten a public address, right? And that public address is a route to different, is a gateway to different communications. So how is that achieved? Now, you want to speak to someone in London, right? You have MTN. This is MTN. MTN gets a public address from the public because they are service providers. Then they give you a private address, and your private address can be 192. You can check your phone now. You can check settings in your phone to see your private address of your phone. So you have your private address. So the private address is basically a name given to your phone. This is in the internet world. This is the name given to your phone, just like my name, just like the way I have my name, Ifeoluwa, right? This is the name given to your phone by MTN. If you change your line to Glo, this Glo will give you another name, which is another private address. So now, how do you now communicate with the world? Because private address are addresses that are private, like the name implies, private, which means they are only for small segment of people, like an organization, like an office. Like if you're in an office right now and you are browsing with your office network, the reason why you can browse with your office network and use your office network is because your office probably have a service provider that is giving you guys internet network, and you can communicate with your devices. You can print using your laptop on your office printer, but someone outside cannot print using their laptop on your office printer, and that is because you are on your own private address. The devices within your private address, they all have a name that they use to identify each other. One example of that name is this IP format. I know we all know something like 192.168.2.256. So if you're on your laptop right now, if you want to check, you can go to CMD. When you go to CMD, type IP config on your CMD. When you type IP config, you are going to see the details of your system's name, which is the IP address of your system. So back to what I was saying, the distinction between the public address and the private address. So when MTN assigns this number to you, this number to your phone, right? This IP address to your phone doesn't know the internet. Your phone doesn't know anything outside the internet world. So what your phone does is, if you want to browse, right? So what you do is, when you browse, your data is routed to MTN public, just like every other people's data that you are sharing MTN with. They are routed to MTN public address. So MTN public address will now receive those data. They will now batch it. It's just like when you want to send something to someone in Osun, right? You go to GIG and you drop your goods with GIG. Then GIG will help you deliver it. That is what this public address does. So when you want to call someone, MTN will quickly plug you to their public network, right? When they plug you to their public network, they will now send your data to the public network of the other person. The public network the other person is subscribed to. So let's say the other person is Glo, right? After use this command. Let's say the other person is Glo. So MTN will now route it to Glo. Glo will now receive that, send that information to the IP address of that other person. That other person can be 172.this, right? So that is how information is passed. So now, IP address addresses devices used to interact with each other. In classless interdomain routing, private address is used to actually ensures that peripherals and devices stays within the same group. And how do devices interact with each other? Devices interact with each other by knowing each other, by being in the same group and knowing each other. So once devices are in the same group, it means they can send data to each other. So say I have my device on 192.168.192.64.26.5. It means my other device is also 192.64.26.8 or .2 or anything. So this means these two devices, they are in the same cluster, they are in the same group, right? So basically, this is just a basic IP address lesson. For you to understand more about IP address, I don't want to go deep into it. You can also go online. I'm going to share some documents with us so that we can also read and understand IP addresses more, so we don't digress too much. So but just know that IP addresses are device identifiers. They are what devices use to identify each other and share data between each other. So if I go back to my slide here, you see that I have this topology. So I have my controller 1, my controller 2, my controller 3, and I have my hub. My hub here can be my switch, right? My switch connected to my router. So a switch is basically a point that allows different devices interact with each other. So when multiple devices are connected to a switch, they can interact with each other through that switch. So a switch allows 2 or more devices to interact with each other. So here I have a peripheral 1, which is the server. I have a peripheral 2, which is controller 1. I have peripheral 3, which is controller 2, and I have peripheral 4, which is controller 3. How do all these things interact with each other? They interact using the what we call the IP addresses. This line you are seeing here, they are TCP/IP ports. They are cables. They are network cables. How many of us know Cat6 cables? Raise your hand if you know Cat6 cables. As an installer, you need to know what Cat6 cable is. And one of the first things you'll be doing if you are selected is to crimp a cable in the offline section. The offline trainings we'll be having for those that will be selected. One of the first activities you'll be doing is to learn how to crimp cables. So these are network cables. These are network cable lines connected to each of the controllers, right? And this is the server that represents the software which these controllers interact with. You understand? So that is the network layer. Now, for cable space, use 4-core for locks. We all know 4-core cables. 6-core for WiGAN. That's the CAT cables. 2-core for the exit switch. So parallel prohibition. Never run power and signal together. So when you are running cable for network and power, never run them together. Never. People make this mistake a lot. This might affect the signal. This might affect you saying, oh, you are now trying to you badge and you are not seeing transaction on the software. These are one of the issues because you are running power and network together, right? So avoid connectors, right? Avoid the use of connectors. The shielding layer must be connected reliably and grounded end to end, right? So if you are using a Cat6 cables and you are doing outdoor, you need to use an outdoor cable shield, and they have to be properly, connected. Never twist wires together.
This password.
So these are the
I
instructions.
send it in the chat. Maybe you
So now let's go to the
ZKTeco
protocol architecture. I talked about the WIGAN protocol. For WIGAN protocol,
yeah,
because you have
for changing
the
password.
So in WIGAN,
Yes.
In WIGAN, you have.
They use the wrong. They give you the wrong.
I explained this. You have the data 0. You have the data 1. You have the 12 volts. You have the GND. So you have this, and this requires the number of strands you are going to use. Although for a complete WIGAN connection, 6 is required, but 4 can also be used because you have just 4 points. So in some cases, we would advise that when you are connecting WIGAN, you double your 12 volts and your ground, especially if your reader is coming from a long distance. When you are connecting your readers to the controllers, so you double your 12 volt and your ground. If it's coming from a long distance, then you can now use one strand from DO to D1. So this, you double 12 volt and ground, then one strand for DO and D1. Now, for the RS485, RS485 works in a what we call bus cascade topology, right? Daisy chain. So you can see here you have the readers, you have them connected together, just like in series format. So let me give a description of that here. So for RS485, you only have 2 points. If I go to the controller where I was showing this, you can see that here we have 1 point for the RS485 reader. You can see 1 point, just 1 point for the RS485 reader, right? So that 1 point, you have the RS485 plus and RS485 minus. Then you have the 12 volts and GND. So for
You're not sharing your screen, sir.
Hello?
You're not sharing where you are now.
Oh, sorry. Yeah, you can see my screen, right? Good. So for RS485, they work in a bus cascade topology. Bus cascade topology is also called daisy chain. It means, say I have
this new username is
these readers. Example of RS485. Can anybody give me one example? Example of RS485 reader.
You can search this name in the database.
We talked about it in the first class. Anyone?
It shows 0.
Anyone?
1.
FR 1200.
Good. Very good. So you have the FR 1200. So to give a description, okay, so that some people will understand, let me cancel this and get a image. I get image from online. So we can use that image. Copy this. Come here, paste it here. All right. So we've all seen this reader before, right? So this is the FR 1200 reader. So for FR 1200 reader, so now, here I was talking about the exits. the card readers. For Wigand readers, you only have 4 points. How about for FR1200? For FR1200 on Inbio Pro 460, you can have up to 8 reader points. So which means for FR1200, for these 4 doors, you can achieve reader in, reader out for all the 4 doors together. So you can see where the strength of FR1200 comes in. So the daisy chain like is, so on FR1200, you have so you have this. I'm going to draw a straight line. The connection is like this. You have the RS25 plus and minus points, right, on each of the device. So you are connecting the RS25 plus, the RS25 minus. You are connecting it to the device. Then you are looping them together. So this is the daisy chain principle. So you are looping them together. You are looping them together. So same thing with the 12 volts to power them. So you can power them separately, 12 volt and ground. You know, if you have a 12 volt panel with greater amps, like up to 5 amps, you can also do a daisy chain like connection. But if you don't have, you can power them, you know, separately, right? Can we see my screen? Can we also see my because someone
Yes,
is
sir.
saying my screen. So you can see it, FR1200, FR1200. So you can do up to 8 of this. So when you have up to 8 of this, you can now achieve the 4 doors. Now, the question you now want to ask is, how do you now, so now that you've looped everything together, you know, if I loop up to 8 of these together, this is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. If I loop 8 of these together, right, how do I know that this one is door 1, this one is door 2, this one is door 3, this one is door 1 in, this one is door 2 in? How do I know all those things? How do I know that this one is for door 1 in? Because I've looped everything together. Unlike Wigand is simple. On the reader, on the controller, I already have the points. I know that Wigand 1 is for door 1, Wigand 2 is for door 2, but on RS485, the point is just there on the controller. So how do I know? So now it now brings us to our next slide here. For the Wigand, I've explained this, the bus topology. So it now brings us to the RS485 switch addressing, right? So it now brings us to the RS485 switch addressing for the readers. One minute. Oh, this is not the. Oh, this dip is for the controller. So let me go to escalate draw. So for the RS485 addressing, I'm going to share something now. Okay. Something very clear. Okay. Okay. So it now brings us to this RS485.
Yeah, I'm still here.
So we can see my screen, right? Let me expand this. Can we see it? Now, How do we identify that this reader is for this door? The way to identify that is the addressing. So on these readers, at the back of these readers, there's what we call the deep switch at the back of the reader. That deep switch is what we use to set the addressing of the reader to the controller. For Wigand, I said for Wigand, the addressing are fixed, right? The addressing are fixed on the Wigand. You know that reader 1 is for lock 1, reader 2 is for lock 2. But how do you set addressing for these RS485 readers? You set that by using these methods. And I'll tell you that this method, this addressing principle, is also same for all RS485 readers. The addressing method is the same, is a standard. So even if you are not using a ZKTeco user, if you are not using a FR1200, if you are using another reader, maybe from HIK, from Dahua, from Pasting, that, this is what Pasting doesn't have a biometric reader. So now, address 1, you have on the back of this reader, you have 8 deep. So if you want to set door 1, I said door 1 is what? The first relay on the controller represents the what? The first door. So that's the first lock point 1. So for door 1 entrance, you set 1 up, you set 1 down, and every other thing up. You understand? 1 down and every other button up. For address 2, you set 2 up, 1 and 3 down, and every other thing. For address 2, you set 1 up, 2 down, and every other thing, every other deep up. So you see this white indicator represent the state, right? So for address 1, 1 down and every other deep up. For address 2, 1 up, 2 down, 2 down, and every other deep up. So with this, you achieve door 1 entrance and door 1 exit for this address. If you do the same thing for address 3 represents door 2 entrance and door 2 exits. Address 4 represents door 2 exits. Address 5 represents door 3 entrance. Address 6 represents door 3 exits. Address 7 represents door 4 entrance. Address 4 represents door 4 exits. So with this, it means you can achieve up to 4 doors, reader in, reader out, using this type of reader. You understand? So if you are troubleshooting, let's say someone calls you and tells you that, Mr. Friday, Mr. Lawrence, please, we need your help at so building. We have a reader, is a fingerprint reader. We noticed that when you punch on one door, it's opening the door in the other side. Please help us with this. We've done every setting on the controller. We've set everything. We are having that issue. You know that their problem is just that the dips were set incorrectly. So when you get there, you just go there, do your thing, and they'll say, Mr. Friday, magic, we've been doing this for the past 4 hours, for the past 1 week, and you just came and you did it in 2 seconds. Wow. Mr. You understand? So it's why it's good to understand the principles. It's not just connecting. It's good to understand. When you understand the principle, there are things that you just do, and you like if someone is telling you, if someone is giving you the issue description, it will you just look like this is, to those people it is big because they don't understand the principle. To you, you understand the principle, and it will also affect you in some way because it might look so easy to you to do, and you just tell the client, okay, just pay me 5,000, I'll help you do it. Just pay me 5,000, I'll help you do it. Then the client will do that. Hey, someone that is a professional that knows it, that knows that he learns this thing, we charge them like 500K, and they'll be saying, this money is too much, but we are having this issue. Let's just give this person. Then they now stumble upon you, Mr. Friday, Mr. Lawrence. Then you now say, no worry, 5K. They'll just look like, and you just get there. You just do it in 2 minutes. You just, although you've solved it in 2 minutes, but the reason why you're able to do that was because you understood it from the first principle. So when you did it, they will now be looking at it like it's a small thing, but it's not small. It's because you understood what their issue is from the first principle. So it's why understanding. So when you know all these things, when people are stating issues, you know exactly where that issue is coming from. So we are almost done. So we talked about the topology. So now on the controller itself, there's another dip on the controller. The dip is also up to 8 pin, and they are unique through the address 1. These dip are for the support people, the support of the ZK, right? We use this to achieve like different things. That's on the controller. But one of the things we've given out for the function of this dip to the controller is the dip 7. If you want to reset a controller, so for ZKTeco, every controller comes with the same default IP, and the default IP of all our controllers is 192. Default IP of ZKTeco controller is 192.168.1.201. This is the default IP we give to all our controllers from the factory. This is the default IP we give to all of our controllers from the factory, 192.168.1.201. So let's now say a client has added a controller, they've used it, they've assigned their own IP, and they are now having issues, and you need to bring down the controller and connect it to your own system. The first thing you want to do is to reset that controller. When you reset the controller, the network changes back to the default IP, which is 192.168.1.201. And how do you reset that controller? You reset that controller using the dip switch on the controller. So the dip on the controller, the dip 7, the 7th pin, you just turn it up, turn it down, turn it up, turn it down 5 times, and the controller resets. So with this, it's also something you are going to see if you are selected for the offline visit to have understanding. You are going to reset the controller. I'm sure some of us already knows this, already have good understanding of how to reset and all those things. So for InBio, I talked about this yesterday, the NC and the COM. Yes, Ahmed.
Okay, sorry, I wanted to ask if, for example, to reset that, let's say you put the IP, does it have like a web-based console that you use to interact maybe probably with a URL? That is once you type that default IP.
Yes, yes. God bless you. For InBio Pro, they have a web-based control that you can access. So we are going to see that in our next class when we are looking at the software, and also software from the controller side and software from the main software side. You are going to see that also. For Inbound Pro, they have a web-based interface where you do some settings. Although that interface might not be needed, it's always useful when you are doing multi-location. The interface is always useful when you are doing multi-location, because for multi-location, you want to assign the server address of all the devices. You want to assign server address to all the devices in all the locations. We are going to look at all that, but let's finish with the physical aspect, which is the connections and all those things. Then we can now talk about the logical aspect that requires setting up the software. Just follow through on the class. So I've talked about the NCCOM and how to connect the log to the controller yesterday. For those that are here, the log relay is what drives the physical, barriers. The log 1, log 2, log 3, log 4. On InBio 260 is log 1 and 2. On 460 is log 1, 2, 3, 4. On 160 is log 1. So we have the exit button, right? The BUT and ground for push button, and we have the sensor and ground for the door sensors. I explained this in the last class. So the auxiliary, the in and the out, the sensors for the auxiliary in, and also auxiliary out, inputs and outputs for alarms. And we have inputs for sensors, outputs for the triggers. So this slide is going to be shared to us. We are going to see that. So the system logic is simple. The trigger for the sensor triggers, the controller receives it, sends it to the auxiliary output. The auxiliary output receives the alarm, releases the alarm sounds, and alarm can also trigger the log to open for everyone to leave the facility if there's a danger. So this is a system logic cascade. And for extension, right, because we might be needing different auxiliary ports, then ZK also sell, I showed us in the last class, the EX 0808, they are extension for auxiliaries. If the auxiliary on the controller is not enough, you can get extensions for those auxiliary and use. Yeah, Lawrence, you want to ask a question?
Yes, please. The last slide.
Yeah.
This one.
Yeah.
That when you have a when you want to engage this controller with a fire alarm system.
Yeah.
Is this what is it? Just the
yes. So so for fire alarm systems, right? You already have you are taking the dry contacts, right? For the fire alarm system, you don't need to use the auxiliary in of the controller. You just need to use the out of the controller, right? So for the fire alarm system, you need to connect the alarm to the auxiliary in of the controller. So because when your alarm, so like let's take for example Siemens. So for Siemens already have the out, right? Siemens control panel, they already have the auxiliary out. The out is what triggers the sound. Pam, 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 pam. But you now want that once there is alarm, once there is any incident, the alarm should trigger the auxiliary in. In that auxiliary in, we can now use linkage to now say when this auxiliary in has been hit with a signal, open this log relay. All these are done on the software. We are going to explore all this on the software. We are going to see how this works on the software. When this happens on this when this auxiliary in is hit with a signal, open this log. When this auxiliary in is hit, close this log. So all those linkage types, they are all on the software. So you now set the type of linkage you want, right? So there are different linkages for doors. There are for auxiliary. So in cases where you are not now using any alarm system that has a control, maybe just regular buzzers, regular alarm buzzers and alarm sensors. You know, you have some sensors that will come like smoke detector, like all those smoke detector that just comes, like they don't have alarm, they are just sensors. So the smoke detectors can now be connected to the auxiliary in. You can now use alarm on the auxiliary out of the controller. So when smoke has been detected, the smoke detector peripheral, the device detects the smoke, sends signal to the auxiliary in, then the auxiliary in can now trigger the aux out, which is the alarm. So when it detects smoke, sends signal to the in triggers the aux out, then the aux out buzzes. It buzzes. You understand? I hope that's clear.
Yeah, that's clear. Thank you.
Yeah. So that's our aux in. So for every controller, you always see the aux in and the aux out. The aux in, always have in mind that the aux in are always for auxiliary sensors like smoke detector, fire detector, anything detector. They are for sensors. Why the aux out? They are for blasters like sound blasters, alarm sensors, that need shots. But in a case where you now have a complete control panels, which some companies will have for like Siemens alarm and all those things, you don't need that. What you just need is a short to the auxiliary in, so that whatever the Siemens detects, it sends it to the controller to now run a logic on the locks, right? So that is how those are used. So we are past our time. So I'll just breeze this through. I want us to also look at the slide, take a look at it. Let's engage in the group. I'm always saying it. I'd expect us to go through the slide, ask questions in the group. Let us answer each other's questions, right? When we have issues with our learning, let us interact with each other in the group. I know we are all busy, but we can take time to engage each other in the group. After this section, the quiz will be shared with us, as usual. So we answer them, and the assignments for the week will also be shared with everybody. So the final part, the indicators on the controllers. So for the controllers, you have different indicator types. You have the power that indicates red. You have the run, which shows that the controller is, running, that the system is working normally. Then you have the card points. That shows the yellow. So when you badge a card, you can also know from the controller. So in some cases, when you are doing troubleshooting and you are badging the card and this light is not glowing, you know that there's something wrong with the card connection. So you can also use this to determine that. So when the card is badged properly, you know that yes, a solid Wiegand input is what's detected, right? So also, when you badge and this green comes up, it shows that an operation has happened, either lock has opened or something has happened. So that's the diagnostic state. And this is just a blueprint. You can take and look at it. It shows the holistic diagram of the mag law, the connections of everything. So I want us to look at it. Is basically all the things we have explained in a single view. So by next week, we are going to be diving into how the device connects to the software. We are going to be looking at the attendance software first. And on the second day, we'll be looking at the access control software next. So we'll be looking at how the device connects to the software. Then we'll be taking a dive into the software itself, which is about time 8. We'll look at that. Then the following day, we'll look at the civil security. And the following week, we'll take a deep dive into each of those applications. So still want us to pay attention. Yeah, there's no rushing. This is till we all understand the product itself and how they work and the concepts around them. So it's 12:05. For questions, so Ahmed.
Okay, I'm sorry. I have one question, and that is from last week that I wanted to ask. Now, let's say, for example, is it possible to convert an ID card to like to use as an entrance? What do they call? Let's say, for example, a company asks you to, okay, I want all our staff ID card to be like their entrance. What do they call it? Like the card that they used to just beep from the entrance to enter. Is it possible to prime that kind of thing?
Yes, of course. They should use card as entrance. They should use their card to go in.
Okay, is it ZKT product that they'll use to do that, or how is the concept? Like how is it done? Like how will they be able to achieve that?
Yeah, so that's where we are going. If we talk about the readers, we talk about the for those in the class, I want to know if everyone gets. Can someone explain the concept to Ahmed? Yeah, Friday.
Okay. My little knowledge though. Yes, it's possible, just like you said. But what they need to do is, because we've done it for someone, the card they will use definitely is not going to be the card that you start a business that they will just use to print normal ID card. No, they have to use the card that are for budget. Let me use a simple, okay, for biometric card. That is what RFID card. That's what they need to use right first, because that is what has the embedded code in it that can be worked on. That is the what would be. Then of course they will have the printing machine for it that will just print the name and all that. Then they will now configure the card, which if you say will be doing the next, they will not configure it on the software. So with that, it will serve for the two purposes. You will use it as a normal batching card, and they'll use it as a card. Yes.
Very good. Very good.
So certainly not the normal card that the business center uses for that.
Yeah. Ahmed, is that clear?
Yes, thank you. But the card you are going to use to print on, can it be purchased from ZKT, or they have to go and look somewhere else to purchase?
So ZK, we are OEMs, but we have distributors, right? You can visit our website if you need a card. I'm sure I think one of our partners, or some of our partners are also here that sells the card, right? So you can ask in the group, but ZK, we don't sell directly. We have distributors, so I can give you a contact that you can reach out to, or if there's anyone here that knows our distributors, they can reach out. Yeah. So yeah, Lawrence.
I wanted to answer his question.
You want to answer? Yes. No, you can answer. You can answer. There are different ways in which you can.
He has explained the way I actually wanted to.
Okay, yeah. Okay, that's very good. One Dochelli.
Okay, great you, sir. Question.
Yeah.
Okay, sorry, there is a place since I didn't get well, because I'm trying to relate to yesterday class where we talked about that some systems are open while some systems are closed. What I mean by some systems are open is those systems are being connected to network. And if I repeat to these BIOS we are talking about now, it shows that the system it has a lamp on, is connected to network and also to software. And my question now is, in a situation whereby I want to close a system, can I still your bio this device now for the connection also?
That's a very brilliant question, and it shows that you are really following the classes, right? So for closed systems, right, you might not so there are two ways. You can use an inbound controller to achieve a closed system, and you can use a biometric device. Closed systems, the way closed systems are achieved is that let's say you have 5 users, right? Those 5 users that are meant to access a particular place, it is not going to change. It is always going to be those 5 users. What you want to do to use InBio, normally by default, you use a biometric device to achieve that, because biometric device has interface, right? You just go to the biometric device interface, add the users on the biometric device, right? You've achieved your closed system, right? So, but with controller is built from, it's built for an open system. But if you want to achieve it with a closed system, it means you now have to get a software, use a software, right? Use that software to populate your access details, access record, user data record. Once that is done, you yank off the software. Then the controller will store those informations, right? Those records. And those records is what the controller will be given. But you know, yesterday I said for closed systems, you are not going to see real-time reports because the system is closed and it's not connected to the software, right? So in that case, it means you are not going to be getting records, right? But those records will be stored. So in the future, if you need the records, you can always connect it to the software, get your records, right? So unlike devices, because they are biometric devices, they have those memories. You can easily access, you know, those records on the device. Plug a flash, print your records without the software, right? But for access control, for controllers don't have a GUI. Software is their GUI. Software is what they used to see, right? So it's why you need to use the software. So you can use the software to convert the controller into an open system. So it's just data transmission. So it's what led to that classification, right? Once the required data has been transmitted and the required access has been permissioned for a particular user on that device, you can yank off the software. The device keeps working the way it should. I hope that's clear. All right, thank you very much, everyone. This slide will be shared in the, it's going to be shared in the drive. I want us to access it to look at it. Videos will also be shared on YouTube, or the videos are also shared in the drive. You can also watch the video from the drive. But to make things easy, the videos will also be shared on YouTube. Thank you very much for sticking with me for these 2 hours. Thank you very much. I appreciate you for staying and, you know, paying attention, being attentive. It means so much to us at ZKTeco, and it means that you really want to learn about ZKTeco. I'm also hoping to see each and every one of you for the physical visits. Thank you very much. I appreciate you. I'll see you in the next class next week. And please endeavor we do all the assignment given to us. The quiz, endeavor we participate and we answer questions very quick. For the assignment, please don't plagiarize and don't steal someone's assignment. You know, in the drive is opened, so don't let us copy. Let's do it willingly with our hearts. Even if you don't know it, just try and attempt to do it. God bless us all. Thank you very much. I'll see you next week, same time. Thank you very much. Bye.
Thank you, sir. Bye.